Good morning, y'all. So, since we are not in school today, I still wanted to keep going with some of our curriculum. We are going to be starting a new chapter after we're done with our test, but I might as well get going on that. So, our new chapter that we are going to be starting is simplifying radicals. So, let's talk about those. You, for the most part, know them as square roots, but we're going to be talking about more than just square roots within this chapter. So a square root, what is it? Is the square root of a number is a value that when multiplied by itself it gives that same number. So there are a bunch that you already know. Like, you know that the square root of 4 is 2. You know that the square root of 9 is 3. You know that the square root of 16 is 4. What I mean by this statement is that if I take 2 times 2, it gets me right back to 4. Square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. And the square root of 100 is 10. These numbers here are rather important. These are your perfect squares. And you really want to know them as we're doing this unit because it makes everything a lot easier for you if you know what your perfect squares are. Now, parts of a radical that I want to identify before we get going. If there is a number out front of that radical, that's the coefficient. We've used that term a bunch of times already. This little, this squiggly mark here, that's the radical itself. I know I've been using that term without defining it right away, but the square root sign, that's what a radical is called. There could be other numbers that are hanging out above the radical itself. This is called the index, and we won't get to it today. We'll cover that in class later. But the index tells you how many times that you are rooting something. So a square root, you're rooting something twice. A cube root, you are rooting something 3 times. And again, we'll cover that in later classes. And then this number inside of your radical, that's called the radicand. radicand. So that is the radicand if it's inside the radical. So today I just wanted to practice with simplifying square roots and simplifying radicals themselves. So what we're going to do is we're going to look at a couple of these examples here, and I'll kind of show you the overall process of doing so. So simplifying square roots. What you want to do when you are simplifying square roots is you want to break down your radicand into factors of perfect squares. So let me write that note down. We're going to break down the radicand into factors of perfect squares. Let me show you what that means. So let's say I'm doing this first problem of the square root of 8. Well, 8 I know I can make by taking 4 times 2, right? So this is the square root of 4 times 2. Now, 4 is a perfect square, right? Because 2 times 2 is 4. So the square root of 4 gives me 2. I can't simplify the square root of 2 at all because it'd be a decimal. So as this simplifies, I get 2 square root of 2. I'll do it again over here with 20. 20 I can break into the square root of 4 times 5. And then again, 4 is that perfect square of 2. So I get 2 square root of 5. Square root of 48. There's a bunch of different ways to go about this one. Let's say that off the bat, you're like, okay, well, I know that I can make 48 by doing 4 times 12. And I would agree with you, but 12 I could also break down a little bit farther, right? So this could actually expand to the square root of 4, and then 12 can be broken down into 4 and 3. And now in doing so, I actually have 2 different perfect squares here. So that makes 2 and a 2 on the outside. And we're going to multiply those with the square root of 3. So my actual answer is 4 square root of 3. Now, maybe you're really good with your perfect squares and your factors. If you broke this down as the square root of 16 times 3 right away, 16 is the perfect square itself. So that would also give you 4 square root of 3. So there's always a bunch of different ways to go about this. But whenever you're breaking down your factors inside of the square root, you want to make sure that that factor can't be broken down anymore because you could be missing perfect squares hidden inside there. Like this 12, I was able to find another perfect square of 4 out of it. So I had 4 and 3 that came out of the 12. And then finally this 45 here. Let's do this one, the square root of 45. I can break that down into 9 times 5. And then 9 is a perfect square, where if I take the square root of 9, it's 3. So I get 3 square root of 5 as my answer. So that's simplifying square roots, but what happens if we run into one that has a coefficient in front of it? If there is a coefficient in front of it, the coefficient will multiply with the perfect squares that factor out. So what do I mean by that? This example here of 4 times the square root of 18, that 4 is going to kind of carry through to the end of our problem, but I still have to simplify the square root of 18 like I have been. So square root of 18, I know that's 9 times 2, and then this 4 is still there. Now, the square root of 9 is 3, so that means I have 4 times 3 with the square root of 2 still left. And 4 times 3 gives us 12. So this simplifies to 12 square root of 2. Let me show you that again with this example here. 2 times the square root of 75. So that 2 is going to still be a part of our problem here. And then the square root of 75, well, that's 25 times 3. And then 25 is a perfect square in itself, which is 5. So that means it's 2 times 5 square root of 3. And 2 times 5 is 10. So 10 square root of 3. Now, I have a in-class worksheet for you guys to work on and practice. What I'm going to do is I'm going to go through the odds on this one and then give you the answers for the evens. And then your homework is actually going to look very similar to this worksheet itself. So let me go through this odds so that way I don't take up too much of your time with a lengthy video. I'll quickly go through the odds. I'll post the worksheet answer key for you guys so that way you can look at and follow along. But the square root of 32, as I break this down, I can say, well, 32 is 16 times 2. And then 16 being a perfect square is 4 times the square root of 2. Now, let's say, for example, that you didn't pick 16 right off the bat. You're like, well, I know 32 can be made by, I don't know. Let's say you said that it was 8 and 4. So 8 times 4. You're like, well, I know 4 is a perfect square, but 8 is not. And 8 can actually be broken down a little bit more because 8 would be 4 times 2, and you still have that 4 there. Well, there's your perfect squares. I've got a 4 and I've got a 4, which makes a 2 and a 2 on the outside, and anything that comes out we're always multiplying, and then a 2 left over, which gives you 4 square root of 2. So either way, you still get the same answer here. Next, let's move on to number 3, square root of 45. I think I did one like this, if not the same problem already. Square root of 45. That's the square root of 9 times 5. And 9 is a perfect square of 3. So 3 square root of 5. Notice that the 5 can't break down, so it's still in my answer inside of the radical. 5, 216. So now we're getting into a little bit of bigger problems. If I'm looking for perfect squares, 216 would be 36 times 6, and 36 is a perfect square of 6. So this gives me 6 square root of 6. Now, you might be saying, Mr. Epperly, I don't really know that 36 times 6 gives me 216. I'm not great with my multiplication tables. That's fine. Let me show you how to break it down in other ways. So 216, always try to go for like 3s and 9s and 16 and 4s right away. Like those smaller perfect squares that can break down fairly quickly. Those are easy ones to start with. So if I did 216 divided by 4, that gives me 54. And then I'm not quite done because 54 is also going to break down. 54 is 9 and 6. So this gives me 4 times 9 times 6. And if I break down 54, it gives me 9 and 6. Now, here's your perfect squares. 4 is a perfect square. 9 is a perfect square. 6 is not, so it's actually not going to break down anymore because it's going to give me 2 and 3, and those are both prime. But 4, the square root of 4 is 2, the square root of 9 is 3, and then that square root of 6 is still left over, so that becomes 6 square root of 6. Notice, same thing, but you just took a different path. You can still get there even if you don't know what the exact, like 36 times 6 gives you 216. Even if you broke it down by 2s, theoretically you could get there. It's going to take you a little bit longer though, so try to know your perfect squares multiplication. Now, 2 more examples. This one I'm showing what happens when we have a coefficient in front. So that coefficient is going to keep kind of carrying through to our problem. So 6 is going to stay right out front there as I break this down. 27 breaks down into 9 times 3. And then 9, that is a perfect square. So the 6 is still there, but the square root of 9 is 3. And then I'm still left with the square root of 3 left over. And then 6 times 3 is 18. So that gives me 18, 18, not 16, 18 square root of 3 as my answer. So whenever you have a coefficient in front, you break down the square root like you normally would. It just multiplies to whatever that coefficient is. And then number 9, now I've got a negative number. It doesn't really change the problem at all. It just, you have to remember that negative is going to multiply here. So negative 2 square root of 48. 48 is going to be 16 times 3. And then 16 is a perfect square. So the square root of 16 is 4. So I get negative 2 times 4 with the square root of 3. And negative 2 times 4 is negative 8 square root of 3. So like I said, I will post the solution and answer key for this in-class worksheet so that way you can get a bunch of practice in. And then I'll also post a homework assignment for you guys to work on tonight. It should look very similar, if not identical, to this in-class worksheet. It shouldn't take you more than a couple minutes. I will be around answering emails today if you do have questions, so please feel free to reach out. If not, I will hopefully see you guys in class on Thursday when we have our test. None of this from today is on your test. Your test is still just factoring some of your exponent rules. Radicals will not be included on your test. Good luck, stay healthy. Hope to see you guys in school.